All right, so when you're getting ready for a flight, what are some sources of weather that you would look at?
So I would look at aviationweather.gov. I would look at just the weather app on my phone as well, and just kind of look at ForeFlight and just kind of see what the weather's like at the nearest airport.
And as far as like weather products, so let's say you use aviationweather.gov, what are some products you would look at?
So I'd look at the METAR, the TAF, and SIGMETs, AirMets in the general area.
Yeah.
Just to kind of figure out if I'm okay to fly.
Right. So you mentioned METAR, what is that?
The METAR is the weather observation that's at that current airport and it's issued at the top of the hour, and it just gives you the general weather that's at that airport for that specific hour.
So I guess what are some of those conditions that would be included?
So it would include the time and date of the current weather observation, and then the wind data, temperature, clouds, whether there's rain, thunderstorms, the altimeter setting, and then there's some remarks also sometimes, depending on whatever remarks they want to put at the end of it.
Mm-hmm. So you mentioned it's every hour. Are there any cases in which they would issue a METAR sooner than that?
So a specie, so any significant weather change. So if somehow, like today, there's in the middle of the observation, clouds just start rolling in, and it's like very significant, that they would issue a specie, and it would say specie at the beginning, and then that would indicate that there's a significant weather change.
You don't necessarily need to memorize like the criteria for the specie, like what the exact conditions would be, because there is a measurement of like the visibility needs to decrease to this much or this much.
That makes sense.
Just basically what you said, understanding what it is and what are some of the conditions. Things like ceiling changes, visibility, maybe high winds is when those would be issued. Cool. So lucky for you, I have a METAR right here.
Okay.
So go ahead and take a look at that and then let me know what that is saying.
Okay, I'm gonna break this up first. Start with the important part. So the airport identifier, my Klima uniform. Don't know where that airport is. Is that okay if I don't know what the airport is?
Dang, you're fine. You don't have to memorize it. So it's Monroe, Louisiana.
Oh, so Monroe Airport, and then the time and date. So it's the 18th at 18:55 Zulu, and the winds for the airport are 040 at 7. Visibility is 10. Light rain, clouds scattered at 800 feet. Clouds broken at 2,000. Temperature is 17, dew point 16. These are in Celsius. And the altimeter is 3018. And let's see. The remarks. This one, the A02, I believe that has to do with the precipitation monitor. And LTG, I believe that's lightning in the distance pre-SFR. I'll get back to that part. The P000, it's not a 5. So this would be pressure gradient or pressure tendency. This one. I've never seen that.
Yeah.
I know that the P is a pressure tendency. I know that.
In this case, no.
Because of the 0?
Mm-hmm.
Where is it at? Hourly precipitation amount. So in 0.01 inches since the last METAR, a trace is nothing? So nothing in the last hour?
Nope. I mean, I'm agreeing with you. Yeah.
Oh,
yeah.
Oh, okay. Okay. That wording doesn't make any. So a trace is like there's nothing?
Mm-hmm.
Oh, okay.
Yeah. So you'd see P just means precipitation followed by the amount.
Got it. So then the other one that I was confused on, oh, the pressure tendency starts with a 5, doesn't have P. Okay. Pressure rising or falling rapidly, pressure, okay. Okay. Got it. Got it. Okay. Well.
Yeah, so it's by the decimal place. So if there was another one that I was going to print out had an 8 in the very last spot.
That means no, P003, so in 0.01 inches since last METAR. So if there was an 8.
Yeah, if it was what was it? There's 3 zeros, so it's
Yeah.
0.0008. So that's the 10th place. So it's 0.08 inches.
So if it was 3 zeros, then the 8, then 0.08 inches? Oh, but then if there was like a 8 in the third zero, then 8.8 inches.
Yep.
Oh, okay. Yeah. Wow. Okay.
You're not expected to know that or memorize that. But
got it. It's good to know.
It's more an exercise to find it.
Got it. Not in here.
Most of the time, you're going to get local weather during a stage check and Checkride.
Okay.
And so
it's not like I won't have that anyway.
Yeah, most of the time that's going to be limited to like this information, which,
This is correct, right? Lightning in the distance to the south.
Yep.
And then pressure is rising or falling rapidly. Falling rapidly.
Yep.
So this is pressure is falling rapidly, no precipitation in the last hour, and then the temperature to the decimal. So this was 6. So this originally said 17, but this is to the decimal, so 16.7 Celsius, and then 15.6 Celsius, and then the dollar sign means that maintenance needs to be checked.
Yep.
Yeah. Okay.
Cool. That was good. So another type of observation would be a PIREP. Do you know what a PIREP is?
So PIREP is pilot reports. Usually they can indicate turbulence, just crazy weather that they've experienced. It could be clear air turbulence, icing conditions, or like ash or volcanic ash that they see that just wasn't reported. So anything that's just reported by the pilot to be given to ATC.
Right. So let's take a look at a surface analysis chart. So first off, what is a surface analysis chart?
So a surface analysis chart will basically show like the different areas of pressure. It can also show you different fronts in the area where it could be windier conditions and just kind of calm and stable areas.
Yeah. So looking at this, see a few different labels on here. So this H, what would that mean?
High pressure.
Right. And the L?
Low pressure.
So how do each of those air masses flow?
So high pressure always moves into the low pressure. So high pressure is always going to be clockwise and like away, like it'll go outwards.
Yeah.
Versus low pressure is counterclockwise but inward pressure, or yeah.
So does it travel towards the surface or upward
Upward.
for low pressure?
Yeah.
Right. And so why would that be important to you when you're planning a flight?
Low pressure is usually associated with unstable weather. So in the areas of low pressure, that could indicate a lot of like windier conditions and just associated with just bad weather overall. And that could include turbulent weather as well.
So would that have anything to do with your choice and direction of flight or maybe your route?
Yes. I do know that low pressure areas, they could include areas that could have rain and thunderstorms. So I would want to try to avoid those areas. as best as I can, just because since the weather is shooting outwards, I do know that I'm going to be stuck with some headwinds and some turbulent conditions as I'm flying through it. And so I would want to try to avoid those as much as possible.
And these lines right here, what are those referring to?
Isobars. So those indicate the different areas of like pressure. And the closer they are together, the windier it is. Yeah. So in areas like up here near Idaho, it could be a lot windier than this general area in Oklahoma.
So you're correct with that. Just before that, though. So this line, if you follow it, it travels, across the entire U.S.
Yeah.
So what is that line indicating? Is pressure different here than here? Or is it mostly the same?
Mostly the same.
Yep.
Well, yeah, so it's just different lines of pressure all through each line or each isobar line.
Yeah. So you say lines of equal pressure?
Lines of equal pressure. Okay.
And then this colorful line right here, this blue one, what is that indicating?
So that would be a stationary front. Or actually, that would be, yeah, or cold front. Cold front. So the only time it would be stationary is when they're like opposite of each other, right? Like red, blue, red, blue.
Okay. Yep.
Yeah.
So what kind of weather is associated with a cold front?
So cold fronts could be unstable weather. So it can include a lot of like thunderstorms, a lot of rain. But on the back end of it could also include like very good visibility versus the front end of it. And heavier wind and just unstable conditions all throughout.
Yeah. So why is that? Why does a cold front cause that?
I'm gonna find that in here. You said, why does it cause that? So cold fronts occur when a mass of cold, dense, and stable air advances and replaces a body of warmer air. Our extreme cold fronts have been recorded. It's so dense it stays close to the ground, acts like snowplow, So the rapidly ascending air causes the temp to decrease suddenly, forcing the creation of clouds.
Yeah, so I guess one of the first things you want to think about is how does a cold front move? Is it slow or is it fast?
They are fast.
Right. And then when it comes in contact with a warm air mass, what happens to the warm air mass?
It dissipates.
Yep. Before that, there's something that causes, you mentioned it about rising air. So what's causing the air to rise?
The heat is rising due to the temperature. Or the wind, so the wind pushing away from, that's pushing from the cold front into the warm is like a lot faster.
Right. So I guess you want to get really specific with that about how those two interact.
Okay.
So think about most common examples of snowplow. So when your cold front interacts with the warm front, it's faster.
Yeah.
It pushes underneath the warm front, and the warm front does this.
Oh, it starts to push itself upwards.
Yep.
Okay.
And eventually it'll just replace it. It'll push it out of the way.
Oh, just like in this picture right here. Okay. As the cold front passes, towering cumulus or cumulonimbus clouds continue to dominate the sky. Depending on the intensity of the cold front, heavy rain showers form and may be accompanied by lightning, thunder, and or hail.
Right. So what, I don't think it says there in the PHAC, but let's get a little even more specific. So what pressure changes can you expect during a cold front passage?
Can you elaborate?
So as a cold front moves through an area, I guess, what pressure changes are going to occur in that area.
Like whether they
go
like,
up or down.
They go down. They go down.
Yep. So as that cold front passes, what kind of weather can you expect?
So on the back end of it would be good visibility, better weather, but it can also produce a lot of like squall lines that could produce a series of thunderstorms. So
thunderstorms in general.
Okay.
Convective activity.
Got it.
And then this red one, what is that?
So it's a warm front. It's opposite of cold. So warm front includes stable weather, a lot calmer winds, but can also associate with low ceilings and higher temperatures.
Yep. So as those air masses interact, what's happening during a warm front? So kind of like you explained the cold front, now let's explain the warm front, what's happening.
So warm fronts usually move slower, typically, and since the cold front is shooting the warm air the warm front to be caused, or like to shoot upwards, they can also involve a lot of temperature drops and has high humidity. And in the summer months, a lot of thunderstorms are likely to develop. And light to moderate rain could involve some rain as well in the summer months because of those thunderstorms. That's all I got for you. Fronts are hard.
So because it's slower moving, it's not as, I guess, violent you could use. But the warm air mass rolls over the cold front and pushes it out of the way.
Pushes the cold front out of the way?
So you can imagine, like a tube of toothpaste, right? Your hand is the warm front, it's going on top and you're pushing out the cold front.
Completely shoots it out. Okay.
Or like a rolling pin or something like that.
Rolling out dough.
Yeah, so it's not forcing itself underneath the cold one, and the cold one isn't forcing itself underneath the warm one.
Yeah.
And so there's not as much vertical
motion. Okay.
So it's a slower action. It rolls on top and pushes it out of the way, but you can still experience precipitation.
Yeah. Just not as heavy as like a cold front.
Yeah. All right, so we talked about cold, warm. Where can you find an occluded front on this?
I think this is the only one up top right here. Right?
Yeah.
Yeah, that's the only one.
So what causes an occluded front?
So the occluded front occurs when a fast-moving cold front catches up with a slow-moving warm front.
Yeah. So what are two types of occluded fronts?
Oh, a cold front occlusion and a warm front occlusion. So the cold front occlusion occurs when a fast-moving cold front is colder than the air ahead of the slow-moving warm front. And when this occurs, cold air, a warm front occlusion occurs when the air ahead is colder than the air of the cold front. What?
All right, what is the last type of front that we have not talked about?
The last type? Stationary front.
So what does that look like?
So on here, stationary one would be this one.
Right.
Yeah, that one right there.
Yeah,
so that's a mix of both cold and warm fronts.
Yeah, so what happens with the air masses at a stationary front?
They're just kind of, it's a mix of both. So both of them are just kind of interacting with each other, and it's causing like really unstable weather. When the force of two air masses are relatively equal, the boundary or front that separates them remains stationary and influences the local weather. For days, this front is called the stationary front. The weather associated with That's kind of on the right track.
Yeah.
So it's a mix of both, and the weather kind of stays there for a few days, and it can, and certain parts of it can associate with really bad cold front weather, and some of it has really bad warm front weather.
Yeah, usually it's going to be lingering weather, like precipitation for a while.
Oh, okay. So
I'd say less likely to be thunderstorms. I mean, in any case, you could have a thunderstorm.
Yeah.
But less likely at one of these.
Okay.
Easy peasy.
No, it's not. No, it's not. Oh. All right. Next.
It's orange dash line. What does that guy mean?
It's a trough.
So what does that mean?
Elongated areas of pressure.
What kind of pressure?
Low pressure.
Yep. So what you mentioned earlier, but what's some weather you can associate with low pressure?
That could be like unstable weather, turbulence areas. That could also include just unstable, violent weather.
Yep. Yeah. Low pressure is just bad because it's drawing in everything else.
Yeah. It's like this, right? No, outwards. Inwards.
You had it earlier. Yeah.
Inwards, yeah. I had a visual of this that I put in my head. High is like outwards like this, but clockwise, and then this one is like inwards, like, yeah. Got it.
So that's a surface analysis chart.
Oh, man. You can really dive deep on this, huh?
Yeah. I mean, it looks really simple, so it's
Yeah.
just it's deceiving.
Yeah,
but-
it's not simple.
Yeah, but you can really analyze every bit of it.
I feel like it is simple once you, like, I'm sure you look at this and you're like, oh, I'm not flying here, I'll fly here. But that's kind of it.
I mean, along any front, or, I mean, just looking at it quickly, any front or an isobars are stacked, no go.
Yeah.
Because
Yeah.
that's what happens. You get that. Along that one, warm front, less likely. Cold front, potentially going to develop into this stuff right here.
Yeah. These are the same maps, right? They're like, oh yeah, same thing.
So how often is a surface analysis chart issued?
Every 3 hours.
Yep. So how would you describe the behavior of the wind along each of these fronts? Does wind usually stay the same? Does it change?
Like over the course of a front? Or like its period?
Yeah. So as the front approaches, does the wind change?
Yeah.
How so?
So with a cold front, when the winds are moving a lot faster than a warm front, and they're a lot more sudden, versus a warm front is kind of slow moving, and you can kind of tell ahead of time, and it just kind of pushes itself over a lot slower than a cold front. Because a cold front, they move a lot faster, and it doesn't stick around for a couple days. It's quick and out of it, and after that, it's like unlimited visibility.
So usually one of the first indicators of an air mass coming into the area, it's going to be a change in wind velocity and direction. So those both will change. So now we'll get into forecasts. What are some types of forecasts that you would use before a flight?
So look at the weather on my weather app, just like a few days prior. And then a little over 6 hours, I would ask for an Outlook briefing from a briefer from Flight Service or 1-800-WEATHER brief. And within 6 hours, I would ask for a standard. And then in the event I need to just check to see if anything has changed or within those 6 hours, I would just ask for an abbreviated. And that's where I would go for that.
Yeah. So glad you mentioned a briefing. Are you legally required to obtain a briefing?
Not necessarily.
Right.
Yeah. But you are required to at least obtain the necessary information for a flight.
Right. Good. I almost got you in that one. I think it's not a misunderstanding, but people assume they have to get a briefing before each flight. It's a great idea, but there's nothing in this book that says you need to call flight service and get a briefing, but you are required to get weather information before every flight.
Yeah.
So how do you do that? You can do a self-briefing. The way it's preferred is like the way we teach it is, like you said, use the weather app a couple days in advance. Hey, there's going to be lightning and thunderstorms on Thursday for our flight. Probably not a good idea to go.
Yeah.
And then you can start to use forecasts, and then you can start to use observations like METAR. Educate yourself as much as possible. And then if you have questions or want additional details, call a briefer. In my opinion, a briefer is the most updated version or updated way to get NOTAMs and TFRs.
Yeah.
The websites even have a disclaimer that say, don't trust this.
Yeah.
So it's like,
Because something might not update by the time you go up in the air, like a pop-up TFR or something.
yep.
Yeah.
So as long as I would always follow that up with getting a briefing. You can do a digital one or over the phone. But I think that's the most updated way to get TFRs and NOTAMs and things like that, like pop-up,
Yeah.
like you said. So another type of forecast would be a TAF.
Yeah.
What is a TAF?
It's a terminal aerodrome forecast. So that's just looking ahead into the future of what the potential weather could look like at that specific airport. And valid for, or they're issued for 24 or 30 hours every 6 hours.
So what area does a TAF cover?
The airport.
Right. And as far as distance, there is a numerical value to that. How far does that distance cover?
Oh. Let me check that.
That
5 statute miles of the center of the airport's runway complex. So of the airport.
Yep.
I didn't know that. Huh. Okay.
Some people ask, how about a METAR? But the METAR doesn't specify.
Doesn't specify it, so it's just the general area of the airport.
Yeah. I mean, it could be assumed it's the same as your
Okay.
TAF, but it doesn't include that wording in the book. So I wouldn't claim that.
Got it. Okay. So 5 statute miles of the airport. Yeah. It doesn't even say it in here. It's just in there.
Yeah.
Okay.
It's kind of frustrating part is you got 3 different weather sources right there.
And not a single one of them actually specifies what it's what. Okay.
So what kind of information can you find on a TAF?
So the TAF would show it would show the time of 6 hours from now of the airport. And it would give a rough estimate of what the wind would look like and the visibility and possible cloud cover and just all information about weather.
Right. So that wind, is that provided in true or magnetic direction?
That's in magnetic. True. That is in true.
Right.
Yeah.
And as far as like cloud height, is that MSL or AGL?
MSL. AGL? AGL. I'm like mixing the two.
Yeah. Lucky for you, I have a TAF right here on hand. So go ahead and walk me through the information that you see.
All right. So, airport identifier, the Monroe Airport, and then this is valid or the time issued. So the 18th at 1741 Zulu, and it's valid between 1800 Zulu to 1800 Zulu of the 18th and the 19th, so 24-hour period. And the winds are 330 at 7, visibility is 6, light rain, mist with clouds overcasting at 1400. That's temporary between 1800 Zulu and 2000 Zulu. The visibility will then be 4 statute miles, rain showers, mist, and overcast at 1000.
Yep.
And then on the 18th, still at 2100 Zulu, it would be 360 at 10, greater than 6 statute miles on the visibility, scattered at 1300, broken 2500. And then 2 hours later, the wind gets worse. It's at 010 at 12, gusting to 19, and visibility is still the same, greater than 6, but it's overcast at 2000. And then about 7 hours later, It'll be 020 at 7, so calmer winds, the gusting went away. And same thing, greater than 6, scattered at 3,000, and then scattered at flight level 250. And then at 1000 Zulu on the 19th, 020 at 5, greater than 6 on the visibility, and then clouds scattered at flight level 250.
Looks good.
All right.
In case you needed it, that one's on there too, but a little easier than the other one.
Yeah.
So are you familiar with graphical forecast for aviation, the GFA tool?
The GFA tool. I've never actually looked at it.
Yeah. Do you know what it is?
Oh, never looked at it.
Okay.
GFA website is intended to provide the necessary aviation weather information and give users a complete picture of the weather that may affect the flight in the continental U.S. The website includes observational data, forecasts, and warnings that can be viewed from 14 hours in the past to 15 hours in the future, including thunderstorms, clouds, flight category, precipitation, icing, turbulence, and wind.
So in your own words, what does that mean?
Basically telling me the future and the past of what the weather looked like, and it'll tell me like the wind, turbulence, icing conditions, just pretty much what a typical weather forecast would, just in much more detail.
Yep. And the method that they do that, is it textual like this, or is it graphical?
Graphical,
Yep.
due to the name.
Yeah. So it's just a map that's overlaid with the weather, and so you get a visual depiction of weather.
Oh, like it'll actually show like clouds and whatnot.
Yep.
Oh, okay.
So what type of weather can it show you?
So it would show me clouds, thunderstorms, could show me wind direction.
Can it show you air mets?
Yes, it can. Because air mets also include mountain obscuration and icing. So and that's part of what the GFA shows.
So winds and temperatures aloft are another forecast.
Yeah.
At what altitudes are temperature and wind left out?
The surface. And left out?
Yeah. So
I mean, usually they're all kind of showing. They're all usually showing, just depends on the speed. Then the numbers are kind of different.
yeah, I mean sometimes when you look at it, there's blank columns, and that's
yeah.
because of the altitude.
Like 3,000, 6,000, 9,000.
Yeah. So let's try to find the answer. So at what altitude is wind left out, and at what altitude is your temperature left out?
So temperature would be left out if it's below freezing or above freezing.
No. So,
Or like on the ground, it'd be like surface winds. It would show like below 3,000. Like nothing would show up below 3,000.
yeah. So I'm looking for the specific altitude that's the cutoff. You're close to it.
2,999. 0 to 2,999.
So where can you find out?
That wouldn't be in here. That'd be in here. Area forecast, wind and temperature loft. Temperatures are not forecast for any station within 2,500 feet of the station elevation. No winds are forecast when given level is within 1,500 feet of the station elevation. Okay,
Right.
got it. So that's the right answer.
And those winds, are those magnetic or true?
They are true.
Correct. So what is a convective outlook?
So a convective outlook is an outlook of convective activity over the course of 3 days and 24-hour periods.
Yep. And what does it usually describe?
Severe and non-severe convection. The severe usually would be tornadoes, wind gusts that are greater than 50, hail, and yeah.
So some other weather advisories you would want to look at are air mets. How often are air mets issued?
Air mets are issued every 6 hours.
And who does that information important to? Who does that apply to?
All pilots.
Yep. And especially hazardous to who?
VFR.
Yep. Or general aviation.
Yeah.
How about a SIGMET? First off, what is a SIGMET and how often is that issued?
SIGMETs are every 4 hours, and SIGMETs are hazardous, but not as hazardous or like as violent as air mets.
What goes in severity? So air met, the least severe.
Oh, then convective is the highest. Okay, yeah. So SIGMETs are more severe than air mets, and usually can include tornadoes, thunderstorms, volcanic ash, dust storms, and heavy winds.
And how about a convective SIGMET?
Convective SIGMET would be issued every 2 hours, and those are a lot more severe than the other two. And those include thunderstorms, heavy winds, and just violent weather overall, and hazardous to all aircraft.
Yep. Other examples would be embedded thunderstorms, hail larger than 3/4 of an inch.
3/4, yeah. That's the one, yeah.
So you mentioned the word stability earlier. What is atmospheric stability?
When a vertical force is like difficult to have. So the PHAC labels it as a vertical motion is like the movement of it is very difficult to like get through, and just keeping everything just in a stable condition. There's not turbulent weather, nothing in terms of like wind and just any crazy weather involved with it. So anytime it's like that, then for the most part, it'll stay stable.
So what kind of weather is associated with stable conditions?
Just calm winds, not necessarily any crazy amount of clouds anywhere, no rain, just kind of calm.
How is visibility affected?
Visibility can be, it'll just stay pretty clear for most of it. No?
Yeah, stability, smooth air, bad visibility. Unstable, not smooth air, turbulence,
Yep.
good visibility. So on days where it's like, wow, it's really clear, I can see all the way to downtown LA, it's bumpy for the most part.
Okay.
So stability is the atmosphere's ability to resist vertical motion.
Yeah.
So if something rises really easy, it's unstable.
Yeah.
If something rises with difficulty, then it's stable. Yeah. So stability, why would that be important during flight? I guess what kind of weather is associated with unstable conditions, and why would that be dangerous for flight?
So unstable conditions would be turbulent conditions. It could also mean very violent winds and overall just violent weather. Could have rain, thunderstorms, and just heavy rain.
Yeah. So the thunderstorm, what are some things you need for a thunderstorm to develop?
For a thunderstorm to develop, we need lifting force, moisture in the air, and a lifting force.
So what are some mechanisms that would cause the vertical development of a thunderstorm?
So there could be fronts, converging winds, trough areas, for the most part.
Yeah. And then what's the most dangerous stage of a thunderstorm?
The mature stage.
Cool. And why would you say that?
It's a mix of both updrafts and downdrafts, and it can include turbulence, microbursts, a lot of wind shear, hail, lightning are some examples.
Yeah. So you mentioned wind shear. What is that?
So wind shear is basically the change of wind direction and velocity at different altitudes, and it can be very dangerous because some of them could be very violent. Going from one altitude to another could be a difference of 30, 40 knots, or some could be helpful in a way, going from 30 to, a higher velocity depending on the direction you're flying.
So with wind shear, why is that dangerous? That makes sense.
So it can include microbursts as well. So that could be an example. You could be flying at, let's say, 6,000 feet, and if it's very powerful enough, it could shoot you straight into the ground. But if you're high enough and it's not so powerful, then it might be okay, but it's going to be very, very turbulent.
Right. Yeah. Turbulence, and especially at low altitudes, you're going to be
Pretty dangerous.
very dangerous, right? So what are some types of icing?
So we have structural and induction.
Yep. What are some examples of structural icing?
So we have clear, mixed, and rime.
How is clear ice formed?
So clear ice is a glossy, clear, or translucent ice formed by the relatively slow freezing of large supercooled water droplets.
Yep.
Yeah,
Textbook.
textbook.
How
Trying to figure out the best way to say that without making it sound so textbooky.
Yeah, water impacts your plane and slowly freezes.
Slowly freezes. Okay, so just like water droplets.
Yep.
Yeah, it's clear.
Yep.
It's not broken up or anything.
Yep. And so your aircraft needs to be below freezing, and it gradually freezes as it spreads.
Yeah.
So rime ice, how is that one formed?
So rime is kind of the same, but it's kind of freezing a little bit faster, and it's not clear, but it's kind of, I guess, opaque. Would be the best way to say it.
Yeah.
Yeah.
And so why is it opaque? Why does it have that color?
Because it's freezing a lot faster. It's not super slow where it's slowly doing it. So as soon as it hits the frame, it's instantly freezing.
Yep. Which of those is most dangerous to you?
I want to say clear, because you can't necessarily see it as much as you can rime.
Right. And sometimes it'll go beyond any de-icing equipment and be impossible to break off. So why would you say icing is dangerous?
It can decrease your performance and your airflow of any kind. And it can also increase drag.
Right. Yeah, anything that disrupts airflow of your wings is going to disrupt lift and increase your drag. So living on the coast, we're very prone to fog. What are some examples of fog and what causes those?
We have radiation fog, advection fog, upslope fog, it's 3, steam fog, and ice fog.
Right. So radiation fog, what causes that?
So usually with radiation fog, it's little to no wind and just a calm, clear night. Yeah.
Yep. And I guess let's get a little more specific with it. So what is actually causing that fog?
Radiation fog may develop on clear nights with usually it forms in low-lying areas. So this type of fog, usually when the ground cools a little too quickly, and so causing that. So it's a lifting force of that. Little to no wind. I don't want to keep reading this. As the sun rises and the temperature, when the ground cools rapidly due to terrestrial radiation and the surrounding air temperature reaches its dew point.
Yep. So in your own words, how would you describe that?
So when the ground is cooling too fast and the dew point is reaching that temperature on a calm, clear night with little to no wind, it's creating the radiation fog in low level areas from there.
Yep. So the name kind of describes it, radiating. So the ground radiates heat. So in the evening, the sun's no longer warming up the ground.
Yeah.
So at night, the surface or the land releases all that heat. So the area just above the ground drops to dew point.
Yeah. And it's a lot cooler. Yeah.
So decreases the temperature of the air above it, reaches dew point, then you get fog.
Yeah.
And then advection fog, what causes that one?
When a layer of warm, moist air moves over a cold surface, advection fog is likely to occur. Unlike radiation fog, wind is required to form advection fog. Winds of up to 15 knots allow the fog to form and intensify above a speed of 15 knots. The fog usually lifts and forms low stratus clouds. Advection fog is common in coastal areas where sea breezes can blow the air over cooler land masses.
Yeah, so it was that first bit, warm, moist air going over a cold surface.
Got it.
Because that's the actual cause of the fog.
So warm, moist air moves over a cold surface.
Yep. Okay. And then it cools to reach its dew point. It already contains the moisture necessary, reaches its dew point. Clouds are formed, then the wind
Blows it on
sweeps
over.
it in. Yep.
Got it.
So during flight, what are some ways that you can obtain weather information?
During a flight, I would ask ATC, ATIS. There's also flight service that I could ask for any sort of new weather that might be along the way.
Yep. And if you have a plane that's advanced enough, some planes will have...
Oh, like, what is it? Not ADSB. FISB?
Will have like NextRad or something.
Yeah.
But yeah, those are the main ones. Contact flight service. You can check ATIS along your route. ATC, workload permitting. That's kind of the...
Got it.
The...
If, like, subject to availability. Yeah.
Let's say you obtain a weather briefing and the weather's a little bit on the fence. What are some ways that you can make a decision whether to continue or not continue that flight?
I would take a look at, like, the TAF, and I would also ask for, like, an outlook of what it would look like in the future. If it's gradually getting worse, I would more than likely not go flying. And if it's starting to get a little bit better, I would still kind of monitor it and see how it progresses as the days go on or as the day itself goes on. If it's getting better, then it just depends on what the minimums look like for myself.
There you go. Yeah. So you mentioned minimums. How would you describe personal minimums? You don't have to go into detail about yours, but maybe what that is.
So it would just basically be, depending on what the weather looks like, it would be like my own minimums that I would have, such as if it's less than 5 visibility, probably might not go flying. But if it's greater than that, then I might be okay with flying.
Right. It's a really good black and white go, no-go decision that you've established for yourself.
Got it.
Because it obviously has to be more conservative than regulations. You can't be less conservative than the law.
Of course.
But yeah, like if visibility is 3,152, right? 3 is like nothing for visibility. So let's say you make, as a brand new private pilot, make your personal minimum twice that.
Yeah.
So 6 statute miles, something like that.
Got it.
Cool. So that wraps up weather.
Okay. Is that really?
Yeah. So we'll get into cross-country planning next.
Okay.